All right, so here's some notes about how to rotate an object about the y-axis. Sounds pretty similar, but we're going to do this with a different shape. So let's take y equals something like x squared, y equals 0, y equals 4, and rotate about the y-axis. This is very similar to how we rotate around the x-axis. We're going to do the whole pi r squared thing, but there's a problem. First, if you graph this, you know what the graph of this looks like. I should say we also want the y-axis too. So if we're going to graph this, I know that 1, 1 is a point, and 2, 4, and 0, 0. Right, here's 2, 4. So we got this equation, and it does go to the left, but I want it to be trapped between y equals 0, y equals 4, which is a horizontal line here, and the y-axis, right? So I want this area here rotated around the y-axis. So we draw our little spinny guy here, and we're spinning around, so it goes into the paper, comes over to this side, comes out of the paper faster and faster and faster, and you'll see you kind of get this mirror image, right? So it'll go over here, it'll go here, but instead of just being a flat object, it's got some dimension to it. So we draw a little oval here, and imagine it going around and around and around and around. And it looks like, a bullet facing down, or it looks like an acorn if you took the top off of it. So we want to find the volume of that shape. This would be a totally different problem if we were rotating around the x-axis. It would look like a top, because you'd have this weird shape here. All right, so here's the thing. I want to do pi times the integral of radius squared, pi r squared, but the problem is, if I'm rotating around the y-axis, I have to have a dy here. Okay, now if I have a dy here, guess what's got to be in here? Y's. I cannot put x squared in here. It would not mesh. The y's here have to match the y's in here. So, a lot of times in these problems, you need to solve your equation for x equals. And if you solve for x equals, that means in terms of y. Because if I solve this for x, right now when it's y equals, I would use the x's. That's like all our old problems. The only new thing is this has to be a dy, and you have to get this guy in terms of y's, which means solve it for x. So here's your extra step. Instead of having y equals x squared, you're going to solve this for x. So square root this side, square root this side. I know it's usually plus or minus square root of y, but I only want the right side since I'm spinning it around and I told you these constraints. I don't want the negative side. It wouldn't really help me. So I had all that work. That wasn't even a ton of work. I did a little bit of work to get x by itself. Now I'm putting this in my equation. Okay, so my equation for volume is going to be pi times the integral of my radius squared dy. And now it's a pretty easy problem, right? Pi, oh wait, what numbers do I go between? Here's another difference. You go between the y's, so what's the y value here? 0 and 4. So I'm starting at this y value, I go up to that y value, so 0 to 4. That's another thing to watch for. These need to be y values, not x values. Okay? So integral from pi 0 to 4, and what's the square root of y, or square root of y squared? It's just y. And now I do my integral trick. So I got pi times bracket 0 to 4, raise the exponent up 1, divide by the new power. That's our integral trick. And now it splits into two parts. The first time I plug in a 4. The second time I plug in a 0. And then what is that? 16 over 2. So 8 pi. Or, you plug that in your calculator, you get 25.1 units cubed, if you're going for exact. So that's not that hard. Let's try one more so you can get the hang of it. Okay, so here's our next problem. Find the volume of the solid rotated about the y-axis and trapped by y equals 1 over x to the fourth, y equals 1, and y equals 6. So, first thing we're going to do is take this guy and draw a picture. Okay, so let me stop for a second here. Okay, so I always want to sketch these. So I'm going to sketch this guy. Y equals 1 over x to the fourth looks like that. So, remember, I only want the part trapped between all these curves. So, kind of have this, goes over there. I want from y is 1 to y is 6. Boom. So it's like this shape here. This one I'm shading. Rotate it around the y-axis. So when I do that, it kind of makes the mirror image, right? But it has some depth to it, so I'm going to give it like this circle on top, circle on bottom. So it kind of looks like a sorry piece if you broke the top off, right? It's solid, it's not hollow, so I don't have to do the washer method. So that's y is 6, this is y is 1. So here's the thing. Once again, I want the integral pi, so volume is pi times the integral from 1 to 6 of something squared, my radius squared dy. The problem is, this equation I cannot use because it's not in terms of y. So off to the side, you have to, because that's in terms of y, that's in terms of y, that's in terms of y. So this guy needs to be in terms of y. It's still pi r squared. Problem is, off to the side, I'm going to have to go like this. Okay, y equals 1 over x to the fourth. I'm going to cross multiply if you write that as a fraction, or do the old Western switcheroo if you've had me before. 1 over y. You just switch their spots. And then fourth root both sides. So I'm going to fourth root this side, fourth root this side. I know it's plus or minus, but I only want the right half again. And fourth root of 1 is still 1. Fourth root of y is down here. Now, a different way to write that is, well, we can leave it like that for now. Yeah, let's leave it like that. No, I'll write it as y to the negative 1/4 power. Because the negative because it's in the bottom, the 1/4 because it's a root. So negative 1/4 power. All right, so now that is what goes here. Because now it's the same equation, I just solved it for this. So y to the negative 1/4 power. Now I can do my problem. The first thing I do is, before I do my integral trick, I square it, and when you raise a power to a power, you multiply the exponents. So you're going to take negative 1/4 times 2, which is negative 1/2. And I have the integral of that. So now I'm ready to do my integral trick from 1 to 6. And I raise the power up 1. Okay, so now it's y to the positive 1/2. And I divide by the new exponent. Dividing by 1/2 is the same as multiplying by 2 over 1. So maybe I'll rewrite it one more time. To say pi is 2y to the 1/2 power from 1 to 6. And now it splits into its two parts. The first time you'll plug in a 6, always. And then the second time you do a minus sign and plug in the other number. Okay, there's still a pi here. And then I'll do 2 times 6 to the 1/2. And then minus 2 times 1 to the 1/2. But I know 1 to any power is still 1. So when it's all done, you get 2.8989 da. Keep that in my calculator and multiply it by pi. I'll do the squiggly equal sign because it's about 9.1 units cubed. So the volume of this crazy shape is 9.1. Hopefully you got it now, that whenever it says y-axis, you got this extra step of getting this solved for x equals. And then it's pi times radius squared. The only other thing you got to remember is those two numbers have to be your y value, lowest y value to your highest y value. All right, that's it. Should help that out. Give it a whirl. Talk to you later, people.